Welcome to Everything is Changing, the podcast where we explore how our world is evolving toward a more sustainable future. I'm your host, Ahmetcan Uzlaşık. Each episode, we focus on key areas driving this transformation: circular economy, ecosystem restoration, energy transformation, sustainable mobility, and water. Join us for conversations with experts, journalists, and change makers who are creating solutions for a regenerative and resilient world.
Everything is changing.
Welcome to Everything is Changing. Today, we're tackling a topic that's more relevant than ever: space cooling in buildings in the face of rising global temperatures. As climate change continues to impact our everyday lives, we're seeing the urgency for effective long-term, passive, and nature-based solutions to curb CO2-emitting energy consumption. Each year is becoming progressively hotter, leading to discomfort in our living spaces and exacerbating the urban heat island phenomenon, a critical issue in cities where dense construction absorbs and retains heat. Since 1990, space cooling demand has tripled, significantly affecting our domestic energy consumption. In fact, a report from the International Energy Agency noted that 2021 was one of the 7 warmest years on record, with cooling now accounting for a staggering 16% of the final electricity consumption in buildings. Here in the European Union, vapor compression technologies dominate the market, providing approximately 99% of cooling consumption, leaving just 1% for innovative thermal-driven solutions. However, there's a significant gap in knowledge and awareness regarding non-vapor compression options, such as natural, passive, and free cooling solutions like cool pavements. To tackle these challenges, we need to identify and engage key actors: public authorities, urban planners, architects, and energy service companies, to foster a better understanding of technologies and develop tailored solutions. Today, we're excited to explore the CoolLIFE project, which aims to create sustainable solutions for the pressing demand. I'm thrilled to welcome our guest, Jean-Sébastien Broc, a senior expert based in France and a partner of the CoolLIFE project. With over a decade of experience in evaluating energy efficiency policies and a PhD in energy engineering, Jean-Sébastien is well equipped to provide insights into making energy savings a reality. Sebastian, welcome.
Thanks for having me.
It's good to have you here. Now, to start, could you maybe explain what space cooling means and what common solutions are available?
The first thing is that in CoolLIFE, we don't address all possible space cooling. We are focused on space cooling as an energy service to maintain thermal comfort in buildings. And obviously, that's especially during warm periods. More generally, space cooling can also be about maintaining specific temperature in spaces like data centers, food storage, etc. But that part is not covered in the project. And one usual risk we see when speaking of space cooling is that it may be directly related to air conditioning system. While in practice, the use of air conditioning system can be relevant in some situations, but that's not always the best way. And the best way would be first to consider possible solutions to deliver energy service, thinking from the actual need. So cooling needs, they are defined generally. They are assessed as the amount of heat that you need to remove from the rooms that are inhabited in order to stay below the target temperature, which is also called set point temperature. Air conditioning systems are one of the solutions to transfer the heat from indoor to outdoor, but there are other solutions to consider. And especially the first step should be always to consider the options to reduce the cooling needs. In practice, for example, at urban level, this means developing or maintaining green areas that will reduce the accumulation of heat in urban areas. At building level, it may mean using shading devices or improving the insulation of the building envelope. This will reduce the natural transfer of heat from outdoor to indoor. Another point to take in mind is the internal heat gains or sources. And here a usual example is lighting. And when we have replaced incandescent lighting with LEDs, this has considerably reduced the heat generated from lighting. Cooling needs can also be reduced by behavioral measures. Here, usually we speak about adaptive comfort, which means that the level that you will consider as appropriate in an indoor environment may vary depending on certain conditions like humidity, the number of successive days with high temperature, and so on and so forth. So obviously, what we want to highlight here is that there are other solutions than air conditioning systems, and that we should start from considering what are the actual needs for cooling.
Thank you. And maybe we should move on to why has space cooling become such a key issue in Europe's energy and climate policies?
Sure. So since the early 2000s, I would say that there is a clear increasing trend in the equipment rate of air conditioning systems. And if there are more air conditioning systems, this results in higher energy consumption from space cooling. Nevertheless, the challenge is that it still represents a very small share of the total final energy consumption in the European Union. That's probably around 2 to 3% of the total final energy consumption. And this is because this consumption mostly occurs during a few weeks per year if you compare to the heating season that will be several months. So that explains why the use of space heating is much more systematic than space cooling. However, there is a clear trend in the increasing equipment rate and the increasing temperature in summer, and especially the case with the more frequent and longer heat waves. That makes that we see peak electricity demand in summer due to space cooling, and that can put the electric system at risk. That can be up to blackout, and this was observed, for example, in Italy in 2023. That's not the only reason why space cooling is an important issue. And I would say even from a human perspective, the main issue is health. The European Environment Agency reported a summary from the literature that estimated that warmer summers and heat waves caused over 70,000 excess deaths in Europe in 2003 and similarly more than 60,000 in 2022. So we see that it is a very serious issue. And when looking more specifically at climate change from the point of view of greenhouse gases emissions, air conditioning system can also represent a major risk because they use refrigerants. And these refrigerants may have a very high global warming potential, which is the contribution that they may have to global warming. And this global warming potential might be 1,000 to 10,000 times more than the one of CO2, which is the most well-known greenhouse gas. So the risk here about greenhouse gas emissions is particularly high when the air conditioning system is not well maintained because you might have leakage and when it is not disposed properly.
And I also assume that there are some challenges in making space cooling more sustainable. Can you also talk about these big challenges that we are facing?
Yeah, so as we deal with building, when we speak about space cooling, that's the built environment. The first challenge is that the renewal rate of the building stock is very slow in Europe. It's usually assessed around 1% per year or even less in some countries. And that's a major problem because new buildings can be designed to limit their cooling needs. They can favor alternatives to air conditioning systems because when we think about space cooling during the design phase of a building, the investment costs are much lower. More solutions can be considered, so it's easier compared to considering the same for the case of existing buildings. One solution to reduce the costs for implementing solutions in existing buildings can be to embark the actions to reduce cooling needs in planned renovation projects. Just for an example, if you try to install shading devices, it will cost less when it is done if you have already planned a facade restoration, because part of the fixed cost of renovation would be the same. However, in practice, the space cooling aspects are rarely considered in renovation projects because they have other purposes. They are made for structural need, aesthetics, reducing heating consumption. And on top of that, the renovation rate, just like the renewal of the building stock, is also small. That's the first point. The second point is that we mentioned that already. In most of European countries, the first energy end use in buildings remains space heating, and this is by far. So this is why there is much less information and awareness about space heating, about space cooling compared to space heating, especially when there are policy measures or projects to improve the energy performance of buildings. If we look at the different perspectives, so from the perspective of the building owners and occupants, the risk is that they will consider air conditioning system as the main or even the only solutions to meet their cooling needs. And this is even worsened by the evolution of social norms, or because consumer will consider space cooling in a hurry. For example, when heat wave is announced and they want to get prepared for that. And we have evidence of this. If you look at the press, every summer you will see regularly articles mentioning peaks in sales of air conditioners, including mobile devices during warm summers. And we cannot say that it is a surprise to see warm summers. There are studies for many years now in raising awareness about climate changes and the increasing trends in temperatures and heat waves. So there is a strong need to anticipate these increasing cooling needs and to organize more sustainable answers. This needs for anticipation, coordination, and planning is also important due to the diversity among buildings owner and occupants. That's not the same to consider space cooling for residential buildings than for offices, for example. And that's not the same to consider the solution according to your income level as well. On the side of the public authorities and policymakers, one of the major challenges is to address space cooling in an integrated way, while the different levels and responsibility are usually spread across jurisdictions level. What does it mean? It means that, for example, the regulations or air conditioning systems or cooling devices in general are primarily set at EU level. At the same time, the regulations for buildings are mostly specified at national level, and urban planning is in the hand of the municipalities. So it means it's also a multi-governance issue, which make it a bit more challenging to address with a comprehensive approach or consistent approach.
Maybe we should also talk about the European Union here. How is the EU addressing space cooling in its policy framework?
As I mentioned, the most direct way it is addressed is through the regulation for cooling devices. The EU regulations cover the dominant space cooling technologies. So to use technical jargon, it's technologies working with vapor compression systems. And this regulation includes energy labeling regulations that will ensure minimum and harmonized information for consumers. This information is about efficiency and energy consumption of devices. Then you have the eco-design regulations that are meant to remove from the market the least efficient devices. And you have also the F-gas regulation that is related to refrigerant that I mentioned earlier, with the objective to plan the phase out of the refrigerants with the highest global warming potential. These regulations are periodically revised to follow the developments in R&D and in the market, and to strengthen the provisions and support market transformations towards more efficient and climate-friendly alternatives. One important point to keep in mind is that EU regulations apply directly and in the same way in all member states. However, their actual implementation may differ from one country to the other because of the market surveillance that is managed by the member states. Then you have a set of directives of energy efficiency, energy performance of buildings, and renewable energy sources that all include some provisions relevant to space cooling. These directives are transposed by member states in national legislations. That's related to the subsidiarity principle, which means that member states keep some flexibility in the ways they can achieve the objectives agreed at EU level. So this is meant also to allow them to tailor their policy measures to national specificities, but that also results in quite some differences, especially in topic like space cooling. If we look more specifically at the directive on energy performance of buildings, that's the one setting the framework for building regulations, both for new and existing buildings. This framework specifies that space cooling should be considered among the end use when calculating energy performance of the buildings. However, as space cooling represents in most cases a small share of the energy consumption of the building, this framework does not necessarily result in provision that would be specific to reduce the cooling needs. The latest recast of this directive that was adopted in 2024 has emphasized the need to consider summer comfort. So let's see in the coming years when member states are transposing these new provisions, if it's an opportunity to enhance the requirements to minimize cooling needs, especially in new buildings, and also to ensure that when there are measures for major renovation, they do not worsen the conditions for summer comfort. We see in parallel the development of regulations for climate resilient buildings, which also can be a way to address these issues. On a more planning perspective, the directive, or let's say a more higher level, the directive on energy efficiency includes provisions for efficiency in the supply of heat and cooling. And especially it requires member states to prepare and regularly update comprehensive assessments on heating and cooling. So these assessments, in principle, they should go from assessing the cooling needs per type of technology, per sector, up to planning policies and measures to promote to meet these needs and promote the development and support of the adoption of most cost-effective solutions. Initially, this was meant, when we look more specifically at the cooling side, to identify and promote, identify opportunities and promote the district cooling. But in practice, what we see when reviewing the comprehensive assessments reported by member states, most countries have focused their assessments and measures on heating, which is normal because heating represents the main share of consumption when considering heating and cooling together. And also because there is a lack of data about space cooling, making more difficult to fill this assessment for the cooling part. In the latest recast of the Energy Efficiency Directive that was adopted in 2023, a new provision was added to require municipalities that have more than 45,000 inhabitants to prepare local heating and cooling plans, which can be also a driver for space cooling to be better addressed. But for the same reason as mentioned about the comprehensive assessment, it is likely that these plans might focus on heating first, except in areas where space cooling is already a critical issue. Then if we look at the part of renewable energy sources, the latest amendment of the related directive was also adopted in 2023. And it has made mandatory the specific target to increase the share of renewable energy sources in heating and cooling consumption. But again, in practice, the focus is likely on renewable heat for the same reason, due to the small share of cooling compared to heating, but also because cooling is mostly supplied with electricity. Nevertheless, geothermal and heat pumps may contribute to this target. The same directive also requires member states to carry out an assessment of the potential of energy from renewable sources and the use of waste heat and waste cold in the heating and cooling sector. This is, for example, meant as an input to the comprehensive assessment I mentioned just before. But for the same reason, it is likely that these assessments are mostly focused on renewable heat and waste heat. A last part of the EU framework is the European Climate Law, and more generally the framework for adaptation. So the Climate Law was adopted in 2021, and it enforced the requirement for member states to adopt and implement national adaptation strategies and national adaptation plans. For most countries, when dealing with adaptation, increasing temperature and heat waves are one of the important issues. However, we see that the way it is addressed vary quite significantly among countries. A last point about the EU policy framework is that since the clean energy for all package in 2018, the EU policy framework aims at promoting an integrated approach to energy and climate issues. This is especially promoted by the regulation on the governance for the Energy Union and Climate Action that was adopted at the end of 2018. And this is meant to consider interactions and coordination, especially in planning, about several aspects. So supply side and demand side of energy together, energy efficiency and renewable energy together, mitigation and adaptation together. One example of that is the linkage between what I mentioned earlier, the assessment of renewable potential and the comprehensive assessment on heating and cooling, also together with what is named now National Building Renovation Plan, and that was formerly named Long-Term Renovation Strategy. In practice, this can help to strengthen the consistency in planning and policymaking because all these strategic documents will then use the same scenarios, the same data, the same assumptions. However, it may also means that there would be a focus on the main issues, and that issues such as space cooling could be neglected compared to heating, for example.
Well, we talked about the European Union. Now, more specifically, what steps are individual member states taking to tackle this issue?
That's a good question, and maybe the first point to raise about that is the major differences in the context among countries. To set this background, we know that 4 countries, that include Spain, Italy, France, and Greece, would represent close to 80% of the useful energy demand for space cooling in the Energy Union. So it means most of the energy consumption from space cooling is concentrated in a few countries. At the same time, there are also countries that are not visible in these statistics because they are small, but that also have or need also to address space cooling because it represents a significant share of their own energy consumption. And that's the case, for example, for Cyprus and Malta. Altogether, this explains why space cooling is addressed in various ways and various extents among member states. And this is not only due to the differences in the needs, in the cooling needs that are related to climate, but also in terms of equipment rates, social norms, etc. We can see that in national regulations for buildings, for example. If you think about countries where the need in space cooling is limited, most often their regulations for building will not really explicitly address space cooling. It will be there because of the requirement of the directive on energy performance of buildings. So it will be considered for calculating the energy performance of the building, but there will be no specific provision, no specific requirement dealing with space cooling. Whereas in countries where it is a much more critical issue, we see a trend in provision such as limiting what is called discomfort. It can be considered either differentiating winter and summer, so considering winter discomfort and summer discomfort, or discomfort all over the years. And here it is to assess the number of hours where the indoor temperature will not be appropriate, either because it's too cold in winter or because it's too warm in summer. And that's an interesting approach because then it does not limit the options considered to technical solutions because comfort is directly related to behaviors, for example. And another point to be mentioned here is how the member states coordinate their actions between the different levels, between the national and local level, because we have spoken about buildings. Building regulation are mostly specified at the national level. But then many parts of the solutions that are needed to provide sustainable space cooling are in the hands of the local stakeholders. and especially the municipalities. We mentioned earlier urban planning and limiting the accumulation of heat in urban areas. So that's one of the examples where the role of local stakeholders, the role of also of urban planners, architects, building engineers is essential.
Jean-Sébastien, thank you for sharing your insights with us. It's been really a pleasure learning more about sustainable cooling solutions and the important work of the CoolLIFE project. Again, thank you very much.
Thanks to you.
And that wraps up our deep dive into the future of sustainable space cooling with Jean-Sébastien Broc. As we have learned, addressing the growing demand for cooling isn't just about technology. It's about rethinking our approach to energy, urban design, and how we adapt to a warming world. The CoolLIFE project is a powerful reminder that innovative, nature-based solutions are not only possible, but urgently needed. Thank you for joining us this journey today. If you found value in the conversation, be sure to subscribe and share this episode with others who care about building a more sustainable future. Perspective is everything, and everything is changing. Until next time.